Hello everyone, we would like to introduce our paper Decoupled Iterative Refinement Framework for Interacting Hands Reconstruction from a Single RGB Image. Our goal is to accurately, real-time, and robustly reconstruct 3D hand model from a single RGB image. Compared to single-hand 3D reconstruction, interacting hand reconstruction faces more challenges. On one hand, tightly interacting hands have serious mutual occlusion and self-similarity issues, which makes the visual features extracted by CNNs prone to confusion and ambiguity. These features result in mesh image misalignment. On the other hand, the interacting hands have complex spatial relationships. This significantly increases the solution space of hand pose, making it more difficult for the network to make predictions. This problem can lead to incorrect predictions of the spatial relationships of the hands. To address these problems, we propose a decoupled iterative refinement framework. Its insight is to solve these two core challenges in two feature spaces with different properties. We define a 3D joint feature space and a 2D visual feature space. In 3D joint feature space, we perform global information interaction between the two hand joints. On the one hand, we hope to mine the kinematic dependencies of hand joints in a single hand, and on the other hand, we hope to model the spatial relationship between the two hands. In the 2D visual feature space, we mainly perform local visual feature refinement. We hope to alleviate the ambiguity caused by similar hand appearances and fill in the absence of visual features caused by mutual occlusion. Overall, we adopt an encoder-decoder framework. We use the global features extracted by the encoder to estimate the initial hand model parameters and insert the decoupled iterative refinement module into the decoding process. Each decoupled iterative refinement module repredicts the hand mesh for both hands. In a single decoupled iterative refinement module, we first extract joint features from the visual feature map based on the predicted 3D joint coordinates. In the 3D joint feature space, we use GCN to perform information interaction within a single hand, thereby using hand skeletal kinematic relationships to reduce the interference of low-quality joint features. Then, we use multi-head attention modules to model the spatial relationships between two hands, capturing long-range dependencies between joint. Finally, we use the enhanced joint features to predict the model parameters of two hands and the spatial relationship between the hands. Then, we project the 3D joint features into a 2D visual feature map through coordinate interpolation. To avoid feature confusion caused by projecting joints back to the same pixel location, we independently project each joint into a visual feature map. We utilize a convolutional module to fuse the projected visual feature maps and original visual feature maps. Joint features with global information can provide strong disambiguation cues for visual features while filling in the lack of image information caused by mutual occlusion. First, we demonstrate the effect of information interaction. Adopting information interaction in 3D joint space can significantly improve the model's understanding of the spatial relationship between hands. As shown in the figure, the model correctly predicts the relationship between the index finger of the right hand and the fingers of the left hand. Here are more examples of hands interacting closely. Secondly, adopting local feature refinement in the 2D visual feature space can significantly alleviate the ambiguity of model estimation. At the same time, it enables the model to pay attention to some estimation errors caused by occlusion or dark. We evaluate our method on Interhand 2.6M. The largest interacting hand dataset to date. First, our method has significant advantages in average joint error and average vertex error. At the same time, our method can achieve better image mesh alignment. Finally, our method shows a better understanding of the spatial relationship of the interacting hands. Furthermore, our method outperforms the state-of-the-art method in PCK at all thresholds. We show qualitative results on multiple datasets. Next, are the reconstruction results of multiple users. Here, we show more in the wild results. Thanks for your time.